Hey kids, Dr. Rones here. We are going to talk about scientific notation again, but this time we're going to have a kind of short and sweet lesson on how scientific notation looks on using technology. So calculator or computers or however you need to get input and output into the technology that you are using. This is a short and sweet lesson, which is nice because the last one was not short or sweet, and so this will be a little reprieve for us. So for this, you see we have a value that we can convert from scientific notation into standard form. Okay. And because I have a positive exponent, then I know that this is going to be a large number. So I have 6.5. I'm going to move this 10 values, place values larger, not 10, 8, place values larger. It's a base 10. So 1, 2, 3, 4, 5, 6, 7, 8. 650 million is the equivalent, right? You could also say that this means the same as 6.5 times 10 times itself, 8 times. That's kind of silly. Or you could say this is 6.5 times 100 million. And either way, you get 650 million. Now, if you had to put this large number into a calculator, this one here, it may not fit, especially if it were much larger. So ways that you could do that is on our calculators, you could do 6.5, the multiplication button, 10, and then use that caret button to the power of 8. Or if you're using a computer, you do 6.5, and then they have the star button, which is also on the 8 button, times 10 to the power of 8. So that's what your input would be. Now, sometimes you will get an output on your calculator or computer, and you'll need to know what that means. So sometimes you might see 6.5 E8. Remember, E means times 10. So 6.5 times 10 to the power of 8. Or sometimes you'll even see 6.5 E8, but you know that those E's means times 10. Some calculators will say 6.5 something like that, a little e, so that means a positive exponent of 8. Or sometimes you'll see 6.5 and then a raised, very small, like so. As long as that is smaller and raised, making it look like an exponent, we assume, if it's a scientific calculator, that this means times 10 to the 8th power. Now, technically, could this mean 6.5 to the 8th power? Yes, technically that could be what that means. But if you're using technology and you know that you're using very large numbers, then you can assume that that's times 10 to the power of 8. Okay? All right, let's talk about a small number. See, isn't this going by fast? So 6.5 times 10 to the negative 8, this is a negative, so I know that I'm going to have a small number. This also means 6.5 times 10 times 1 over 10 to the 8th power, remember? I can turn this into a positive exponent. And if I multiplied that, I could also say 6.5 over 10 to the 8th if I multiply across. That's kind of weird. Or you could say 6.5 over 10 times itself, 8 times. Getting kind of crazy here. Or you could say 6.5 over 100 million. Either way, when you divide it out, you're going to get, there's your 6.5, 1, 2, 3, 4, 5, 6, 7, 8, this decimal here. All these mean the same thing. They're just a different form. And those we do all by hand. Now, if we need to calculate using technology, this may not fit in your calculator, so you need to know how to put this in your calculator. You could either do 6.5 times 10 to the negative 8th. This would be a negative, not a subtraction sign. That's below the 3 button on your calculator. Or 6.5 times 10 to the negative 8th. Oops, I didn't put a caret in there. Sorry. Okay, so that's would be for a calculator or for a computer. That's your input. And your output, if it can't handle a number that small, it might say 6.5 e negative 8 or EE negative 8. It might say 6.5 E08. That's negative, right? That was positive. This one would be negative. Or 6.5 and a little. No decimal. And a little. Negative 08. And again, this could technically mean 6.5 to the negative 8th power, but again, you would know if you were using the technology if you were using very small numbers or not, and if that might be a logical place where technology would use that sort of notation. So you should keep these notes on hand because you will want them for your homework. I really like this homework assignment. And so you will have two values, a large one and a small one, just like our notes. And your job is to shade the boxes that have the same values as 4.1 times 10 to the 7th power. So, for example, what can we find? 4.1 times 10 to the 7th. I believe we have this on our notes. Yep, I had one just like it. Okay, so that would be one that you would shade. Now you'd have to be thinking about these things. 4.1 times 10 times 7, that's different. 10 to the 7th means 10 times itself 7 times, not 10 times 7. So this would be no shading. Okay, and then you would repeat that process at the bottom. And if it helps you, I will give you the clue that there are 8 boxes to shade on the top and the bottom. Okay, it's a little special treat you get for watching the video. Okay, that was such a short lesson. If you need more help, please don't hesitate to ask in class or before school or in homeroom, or send me an email. Rochelle. Yes, I know my email address. All right, shoot me an email. I'm happy to help. Thanks so much, guys, and I'll catch you in class. Bye.